Assalamu alaikum students. Welcome to the lecture of chemistry. I am your teacher Sumayya Khan. Students, we are learning the chapter adsorption and colloids. In our previous lecture, we have already learned what is mean by adsorption, what is adsorbent and what is adsorbate, and what is mean by desorption. These are the few important terms which we have learned in our previous lecture, and I hope you all remember these terms till now. Let us start with today's topic. Today we are going to see types of adsorption. Adsorption is a phenomena in which a substance accumulates on another substance. The substance which gets accumulated is known as adsorbent, and the substance getting adsorbed on the adsorbent is called adsorbate. For example, if you take out a water bottle from the fridge, you will find that the bottle surface get covered with the condensed water on it. Okay, this happens due to what? Adsorption of water molecule on the wall of that bottle. Okay, this is what? Adsorption. The bottle is your adsorbent and the water molecules are your adsorbate. Okay, now let us see the types of adsorption. The types of adsorption is done on the basis of the nature of forces that are involved in holding the adsorbent and adsorbate together. Okay, so let's see the first type of adsorption, which is known as physical adsorption or physiosorption. When the adsorbent such as gas molecules are accumulated at the surface of a solid on account of weak van der Waals forces, the adsorption is termed as physical adsorption or physiosorption. Look, physiosorption is one of the most common type of adsorption which we observe in our day-to-day life. For example, on our skin we find that there is accumulation of dust particles, water molecules, and other kind of oil and other kind of dirt. This is what is happening. Our skin is accumulating these things on the surface, but these things cannot penetrate inside our body. The dust particles are not penetrating, they are just present on the surface making a layer. And this is happening due to the presence of the weak van der Waals forces which are universal in nature. Weak van der Waals forces are everywhere there. Okay, so these kind of adsorption does not require a very huge amount of energy, and it is very common to observe. For example, when we wake up in the morning, we find that on our refrigerator, on our showcase, on our window, there is a layer of dust particle sitting. Okay, what is this? This is an example of physiosorption. Why these dust particles are sitting there? Because of the van der Waals forces that act between the surface of the adsorbate and the adsorbent. Understood? So our adsorbents are what? The dust particle, the gaseous particle, or whatever it is. It can be liquid also, and it is getting adsorbed on our adsorbate, which could be anything. Okay, let's see. The van der Waals forces are similar to forces causing condensation of gas into liquid. Look, the condensation requires very small amount of energy. For example, you are not providing any energy to the water bottle so that the water get condensed on the wall of that cold bottle. So this is what the kind of force is similar to the force which is required for condensation. But all of us know that these adsorption processes are exothermic in nature. So heat is released in physiosorption also. The heat released during physiosorption is of the same order of magnitude as heat of condensation. It means that the amount of heat release is quite less. Okay, though it is exothermic heat releasing process, but the amount of heat which is released is quite less. Now, due to weak nature of van der Waals forces, physiosorption is also weak in nature. You can easily remove the dust particles from your window just by wiping it with a cloth. You don't require any chemical to remove that dust particle. Why? Because the van der Waals forces that were holding the dust particle to the surface of the window is very weak. So the nature of force which is involved in physiosorption is quite weak and it can be easily broken. Okay. Next is the adsorbed gas forms several layers of molecules at high pressure. If there is too much dust in the area, you will find a thick layer of dust particles sitting on the your showcase or refrigerator or whatever it is. Why? It is not a monomolecular layer. Okay, depending on the amount of pressure or amount of gas or whatever it is particles adsorbent present, there can be possibility that more than one layer or multi layers of adsorbent may form on the adsorbate. So multi-molecular layer of adsorbent may occur on the adsorbate due to physiosorption. The extent of adsorption is large at low temperature. So it is favored by low temperature. Physiosorption is favored by low temperature. The equilibrium is attained rapidly and the physiosorption is readily reversed by lowering the pressure. It means that you can reverse the physiosorption. For example, uh, the water molecule that was there on the water bottle can be again converted back into the vapor form. The water which was the moisture which was the water which was in the form of moisture in the atmosphere was condensed on the water bottle, that can be reversed. We know that these water molecules may evaporate back into atmosphere. So physiosorption is what? Reversible in nature. Now next kind is chemical adsorption, which is also known as chemisorption. Chemical adsorption is also an important type of adsorption, but here the force that holds the adsorbent to the adsorbate is different. It is a chemical bond or chemical force that holds the adsorbate and adsorbent together. When the gas molecule, here it is mentioned gas, but it could be anything also. Okay, so when the gas molecules accumulate at the surface of a solid or adsorbate by means of a chemical bond, be it a covalent or an ionic bond, the adsorption would be called as chemical adsorption. So when, for example, all of us have seen the rusted iron. The rusted iron or corroded iron is what? In case of rusting of iron, what happens? The iron reacts chemically with the oxygen which is present in air and forms iron oxide layer on the surface of that particular thing. So rusting of iron is an important or very common example of chemisorption, where a metal which is your iron is interacting with the adsorbent oxygen and it forms a chemical bond with oxygen and forms metal oxide, and a single layer of metal oxide is formed on the surface. Okay, so chemisorption is very specific. It is not happening randomly. For example, on our skin a dust particle can also accumulate, oil can also accumulate, moisturizing cream can also accumulate, water can also accumulate. But in case of chemisorption, what happens? It is not it is very specific. Physical adsorption was not specific. Okay, but chemisorption is very specific. So this ion will react with oxygen, but it is not going to react with like hydrogen or nitrogen or any other molecule that easily. Okay, if you place the oil on the iron, it is not going to make bond with that oil. So chemical adsorptions are very specific in nature, and because of that specific nature, what happens, they are also irreversible in nature. Like physiosorption, chemical adsorption is also exothermic in nature. It also involve what, release of heat during the process. Okay, this is the similarity. Both chemio and physical absorption involves evolution of heat, and they are exothermic in nature. Now, the heat evolved in chemiosorption per mole of adsorbase is nearly the same order of magnitude as that accompanying chemical bonding. It means that the heat or the amount of heat evolved during the process is high. Okay. Chemiosorption involves a large energy of activation and referred as activated adsorption. Look, this chemioabsorption requires will happen at a particular temperature. It will not take place below at very lower temperature. So chemioabsorption is favored by high temperature because for take that chemical reaction to take place, some amount of heat is required. Okay, that is, energy of activation is required for particular chemical reaction. Every chemical reaction involves a particular energy of activation. So that energy of activation can be achieved at quite a good temperature. So these chemiosorption involves or are favored by the high temperature, because in if the temperature is high, more number of ion molecules or atoms will have that energy of activation. So chemiosorption increases with increase in temperature in the beginning, but after certain limit, if you go on increasing the temperature, you may find that it is not favorable at a very high temperature. But in the beginning, you will find that the chemiosorption is favored by increasing temperature. Okay, so let us discuss the difference between physiosorption and chemiosorption. Physiosorption, the forces operating are weak van der Waals forces. We have discussed it. In physiosorption, the van der Waals forces are responsible for holding the adsorbate and adsorbent together. In case of chemiosorption, what happens? A chemical bond is formed between the adsorbate and adsorbent. And this is what a strong force of attraction. Okay. Second point is physiosorption not specific in nature. They are non-specific, whereas chemiosorption are highly specific and occurs only when chemical bond formation is possible between adsorbate and adsorbent. Example of both for both are given. For example, for physiosorption, adsorption of any gas on charcoal, and for chemiosorption, adsorption of oxygen on tungsten, on iron, adsorption of hydrogen gas on nickel, etc. Third point is the heat of adsorption is low and lies in the range of 20 to 40 kilojoules. So I have said that the heat of adsorption is very less for physiosorption. So there is no very high energy of activation required for physiosorption to take place. For chemiosorption, higher heat of adsorption is needed, and it lies in the range of 80 to 200 kilojoule. It is printed wrong here. It is not 40 to 200, but it is from 80 to 200 kilojoules. Fourth point, physiosorption occurs at low temperature and decreases with increase in temperature, whereas chemiosorption is favored at high temperature, and the extent of chemical equilibrium is lowered at very high temperature due to bond breaking. It means that if you go on increasing the temperature for the reaction, it is possible that the temperature becomes so high that it breaks the chemical bond. The atoms will gain so much energy so that they will break the chemical bond. Next point is, for example, at low temperature, nitrogen gas physically adsorbed on iron. Nitrogen gas physically, it is not having any chemical bond with nitrogen. It is not forming any compound with nitrogen. Okay. Whereas, for example, nitrogen gas chemically adsorb on iron at high temperature and forms a layer of iron nitride. Here you will find that a compound is formed at the surface of the adsorbate. Okay, so here adsorbent and adsorbate are reacting and forming some compound. Next is physiosorption is reversible, whereas chemiosorption is irreversible in nature. The last point is in physiosorb layer may be multi-molecular layer of adsorbed particles under high pressure. I've said that you may have the several layer of dust on your window depending upon the pressure of the air dust that is outside. Okay, so in case of physiosorption we may have the multimolecular layer, whereas in chemiosorption there will be what, a monomolecular layer on the surface of the adsorbate. I hope you all have understood what is mean by physiosorption and what is chemisorption.